Okay, in this video what I'm going to do is I'm going to talk through a practical to measure elastic hysteresis, and this uses some very simple equipment setup. Essentially we've got an elastic band wedged between two blocks, so it's now its current resting phase, and then we've got a meter rule, and this stick is basically going to be our measure point for working out the extension of the elastic band. And then we're going to add force in the form of load onto this elastic band, and then I'll talk through how we put this into a graph and understand what's going on. Okay, so what we're going to do to start with is let's just take an initial 0 force reading for extension. Okay, so what I need to do at this point is I need to get nice and level with this, and I'm just going to take a reading where it meets the ruler, and that's currently at 40.5. So it's 40.5 centimeters. All right, and I'll go through the graph side of this in a minute. And then what we're going to do is just add 1 Newton of mass, or 100 grams, to this, and then just turn that, and then get nice and level with it again. And now it's at 38.6. All I'm taking down is my raw data, okay, and then I'm going to work out extension from that at each phase. Okay, so the next one is at 36 on the dot, and then the next one is at 32.1 centimeters, and then we'll do another one, and now that is at, what's happening there is that elastic band is continuing to stretch, so we're starting to hit a point where that is beginning to go beyond the limit of proportionality, and it is continuing to stretch at the moment. Okay, so 20, it's just hitting out at 27. I think I'll manage probably one more. This might snap. We don't want it to snap. What we want to be able to do is we want to actually unload this material. So let's just see where that ends up at. So that's at 22. And what I'm going to do at this point is I'm going to begin to unload the elastic band and see where we end up at. Okay, so we were at 22. Now when we unload that, so we were at 5 newtons, 22, 4 newtons, we're at 23.5 centimeters. Take off another one, and we are at 27.1, and then we are going to take off another one, and we are at 32.5, and then 1 Newton, and we are at 36.9. And then if we take off the mass completely, what we'll probably find is that we've stretched this ever so slightly. Yeah, we have stretched this ever so slightly, which is fine. We can still use this data for what it's worth. 39.7. Okay, and that's essentially the practical. Now what I'll do is I'll go through the data. Okay, so here's the raw data. So we've got force that was added, and then we've got the extension here that I was measuring during the video, and then I've calculated the difference at each stage, and it's this that we're going to use. What I've done, and the unload is here. And what I've done with this information, I've just put it into a neater table. Okay, so we have the force added. We have the extension, which is the difference between each of the stages where we added a force. And what we're going to do to start with is just going to plot this data onto a graph. Okay, so let's start off just by, and I'm going to do this in green pen, like a felt pen, just so you can actually see what's going on. All right, now generally speaking, you do this in pencil. So we're going to put force in newtons at the side. So there's going to be 1, 2, 3, 4, 5, and we'll put 6 on there as well. And then we're going to go, we basically need to cover up to 18.5 in extension. Okay, so there's the data. So we'll go up in 2, 4, 6, 8. Yeah, we'll go up to there. So we've got 2, 4, 6, 8, 10. And then this is the extension. We'll do this in centimeters for the sake of this today. We should probably work in meters. Just level that off. And then we can start to plot our data onto the graph. Okay, so the first point that we need to find, essentially, so 0 force just here, and we have an extension of 0. So we're going to start there, and then we have 1 Newton, which goes to 1.9 centimeters. So it's about there. Then we go to 4.5. So 2 newtons, 4.5, so that goes to about there. Then we go to 8.4 at 3 newtons, to just there. 13.5 for 4 newtons, so about there. And then 18.5 at 5 newtons, which is about there. Now what you'll notice is we start in a fairly straight line here, and then we're starting to curve. Okay, so we've gone, as we said, we've gone past the limit of proportionality, and what that actually gives us is this curved, again, so we can kind of draw a line like that, so we can see this curved line that's beginning to develop. Now what we're interested in now, so this is obviously the loading phase, so that's where we're going that way. Now what we're going to do at this point is I'm going to just reverse this and see where we end up. So at this point we're going to need the data below. So this is the unloading data that we're interested in here. So let's just, I'm just going to fold this over so you can actually see the data as I plot it. So we'll start off with, if we start at this end, now obviously we start at 18.5. Okay, so this point still exists, and then we go to 17 for 4 newtons, so 4 newtons, and it takes us to about here. Now what you'll notice is immediately we're going to start to come down like this. Okay, so we don't follow the exact same route back, and that's really important. 13.4 at 3 newtons, so that is roughly there again, so you can see that shape starting to form. 2 newtons, 8, 1 newton, 3.6, so there. So we're almost back to the start now, but what we need to realize is we don't actually make it back to the original starting point because we actually overstretched. So it goes back to about there. So then we end up with this graph like that. So this is the unloading section. Excellent. Now what this tells us next, so we've got this big section in here. Okay, so the area between the lines, now this actually represents something. Okay, so when we take an elastic band, okay, and we stretch it, so here's an elastic band and we stretch it and we unload it like that, there's an energy transfer. So energy goes in. Generally speaking, in this particular case, it's gravitational potential energy, and as this pulls on the elastic band, gravitational potential energy is converted into elastic energy. So gravitational potential energy into elastic potential. And then when we unload, okay, that elastic potential is converted a little bit back into gravitational potential energy. But what we need to understand is we haven't ended up at the same point as where we started. What that means is there's a bit of energy loss. Energy loss, okay, so, and that energy loss comes in the fact that the elastic potential energy is also converted into heat, okay? And this is waste, obviously this is a waste energy, all right? But this area in here, if we could calculate the size of this area, we could calculate the heat in joules, okay? And we'll go through that in a later video today. But this essentially covers the practical. So we can see the loading and the unloading of an elastic material. We don't follow the same line essentially between the loading and the unloading. Okay, so it's actually taking more force to load this thing than it is to get it back. But what we can also see is that we've got this stretching of the elastic material as well. Okay, so we'll go through this in another video later on.